Allacademy. Always with you.
Students, welcome to this online video lecture on fluid mechanics. So in the previous session we have discussed the surface tension, then we have discussed the classification of fluids. So in this session, today we are going to discuss the very important topics in the module 1, that is cavitation we will discuss. Then we will discuss the capillarity phenomena. Then we will derive the expression for capillarity rise and fall. So without wasting much time, let us begin with today's session. So what is this cavitation? So you have heard this word while studying the EME, because in a EME subject you are having in the first module the turbines and other types of classification of turbines you are going to study, and this cavitation you will going to study in the damages or the drawbacks of some problems that occurs in pumps and the turbines. So this cavitation is you can say that it is one of the drawback, or it is a phenomena which damages the components of turbines. So in liquid, in a liquid flow system, the pressure at any location in a liquid may be dropped below its vapor pressure. Okay, during the fluid flow, the pressure at any location, it may drops to its below the vapor pressure, and this causes the vaporization of a liquid and results in the formation of small cavities of vapor bubbles. Please note that when this pressure drops, when the pressure drops below the vapor pressure, this causes the vaporization of liquid. Liquid, as a result, the formation of small cavities of vapor bubbles are formed, and these vapor bubbles are dissolved in the gases or the fluids. Now the vapor bubbles so formed are carried by the flowing fluid, means along with the flow these vapor bubbles are also carried out along with they will flow along with the fluid, and from the low pressure region to high pressure. They will flow from the low pressure region to high pressure region, where they will collapse suddenly and generate very high pressure waves. So they will generate a high pressure waves. Here you can see these bubbles. So these bubbles they travel from low pressure region to high pressure region, and at the high pressure region they collapse suddenly and forms the waves. You can see here the high pressure waves, you can observe it here in this section. So this pressure developed due to the collapsing of bubbles may cause the pitting, erosion and fatigue failure of the adjoining solid surfaces. So I will show how this cavitation affects the solid components of the turbines and the compressors or the blades on the blade surfaces in the next slide. So this will forms the erosion and the fatigue pittings on the solid surfaces. This destructive phenomena due to the bubbles that causes the high pressurized wave is known as cavitation, which results in the noise, vibration and loss of efficiency and the damage of the machines. So hope now you got what is cavitation means, because many students will not able to write. They know this is some which causes the small pittings and small holes on the surface of a fluid, but how it causes? It is mainly when the fluid, along the fluid flow, when there is a drop in the pressure, and this drop in the pressure, if it is below the vapor pressure, then it causes the vaporization of liquid, and these liquid forms the small vapor bubbles which will flow along the fluid, and when they flow from lower pressure region to high pressure region, these bubbles they explode or they will collapse, and they will form the high pressure waves. Due to these high pressure waves, they hit very in a pressurized way, in a pressure manner, they will hit the surfaces and they will cause the small pittings and small holes on the surface of the components. So that will reduces the efficiency of a component, then that will damages the machine, that will create the noise and vibrations in the machine components. Now let us know what is this, in which all phenomena, in which all areas these cavitation is observed means, in especially in hydraulic machines such as turbines, pumps, propellers. So it can be sensed by characteristic tumbling sound. So when these cavitation is started in the machines means the tumbling sound is observed. Tumbling sound is observed. Now to avoid this cavitation, so how to avoid this cavitation, that is also very important. So cavitation, obviously this will going to create, but if it is created, how we need to avoid it? So we need to avoid this cavitation. So we can avoid this cavitation at any point in a fluid flow should not allowed to drop the pressure below the vapor pressure. So as it is, these bubbles are formed when the pressure drops below the vapor pressure. So we need to take care that the fluid flow at any point, it should not drop its pressure below the vapor pressure at any local temperatures. Now one more thing is to avoid the problems related to flow of water, the pressure should not be permitted to fall below the 2.5 meter of water. So if the water comes 2.5 below, or it comes below the 2.5 meter, obviously these cavitation process or these cavitation will going to start, phenomena will going to observed. Now here you can see these pictures, how these cavitation affects the phenomena. As I said, the whatever bubbles are they form, vapor bubbles are formed, they will explode and they will form high pressurized waves, and due to these high pressurized waves, here these are the problems which we observe due to the cavitation. So you can observe this, and if you are having, you can observe even in your homes, if you are having any components, the fluid components, you can observe it like turbines or pumps. You can get a pumps in your home, so you can observe these things. So these are the cavitations, these are the problems caused by this cavitation phenomena. So how we can avoid this one? Only we can avoid this problem by taking care that the fluid will not comes its pressure, means the fluid pressure will not drops below the vapor pressure. I hope you understood this, the cavitation phenomena. The next very important topic is capillarity rise and fall. So before that, what is this capillarity? A capillarity is defined as rise or fall of a liquid surface in a small tube relative to adjacent general level of a liquid when the tube is inserted vertically into the liquid. So assume here you can see this one. So according to definition, it is the rise or fall of a liquid in the tube, in a small tube, when this tube is inserted vertically into the liquid. Here you can see this, when I insert this one, so this is a surface, but the water level is moving upwards, means it is rising when compared to adjacent layer of water. So this is a capillarity phenomena. Now let us know some of the important terms in this capillarity phenomena. So the small diameter tube, so whatever the diameter tube is there, we call it as a capillarity tube. We call it as a capillarity tube. And the curved surface, so here you are observing a curved surface on the liquid in the tube is called meniscus. Again, there are two kinds of meniscus. One is a lower meniscus and upper meniscus. We have we categorize these meniscus and upper meniscus and lower meniscus. Now the rise of liquid surface is called capillary rise. Okay, when the fluid comes, this is an adjacent layer. When I insert the tube, if the water level in the tube comes over the adjacent layer, then it is a capillarity rise or capillary rise. Similarly, if the water level comes below the adjacent layer of water, then it is a capillary depression. It is a capillary depression. Generally, this capillarity or capillary rise or fall is expressed in terms of mm of water or mm of liquid, meter of liquid or mm of liquid. So generally it is expressed in mm of liquid or meters of liquid. Now the capillarity is due to, why this capillarity we observe, why this rise is observed? It is mainly due to the cohesive and adhesive force between the glass and the liquid molecules. This capillarity is mainly due to the cohesive and the adhesive force between the glass and the liquid molecule. So hope now you got what is this capillarity rise and capillary fall. Now let us derive the expression. So how to determine what height it is having, how much water is raised. So how we can identify? So we have an expression for this one, that is capillary, the equation for capillary rise and capillary fall. Now let us consider a small figure. You can see this one. Now in the first figure you are observing capillary rise because the water is rising, means the water level is at the top of the adjacent layer of a liquid. In this case, in the second case, the water coming below, this is a capillary fall. So this is the first one is a capillary rise and second one is a capillary fall. Now let sigma be the surface tension of a liquid. So because the surface tension is also very much essential. Now sigma be the surface tension of a liquid and rho be the density of a liquid. Whatever density I have taken, whatever fluid I have taken, it will be having some density. So that density I have to consider. Then h be the height. So either it may be capillary rise or capillary fall. So h be the height of a liquid tube. Okay, and theta, that is alpha you can say that alpha or theta. In some textbook they have mentioned as a theta, and here I have taken alpha. So alpha be the contact angle as shown in this figure. You can see this alpha here, and even you can see the alpha, or some as I said in some textbook they have mentioned as a theta. Now the magnitude of a capillary rise and depression or fall in the circular glass tube can be determined by the following forces, by following the force balance. Now water in the liquid means the water or water in the whatever the raise is observed, the liquid that is raised or lowered in the tube can be given by the area of a tube, means the area, what is the area of tube into rise, that is nothing but h into rho into g, density into gravitational constant. Now area of a tube can be identified by using pi by 4 into d square, because I know the diameter of a tube. Now h is a height, whether it may be a capillary rise or it is a capillary drop. Now similarly rho is the density of a liquid which we have considered in this experiment. Similarly g is a gravitational constant, that is 9.81. Now from this equation I can identify the quantity of water raised or lowered in the liquid or in the glass tube or in this capillary tube. Now again the vertical component on the of the surface tension for a given by, means for this vertical component is given by sigma, that is sigma is a surface tension, cos alpha means the angle, okay, cos alpha into circumference. The circumference is given by pi into d. I have sigma, cos alpha can be identified, then the pi into d. So now for equilibrium condition, by equating this one and the rise of liquid in a tube, so we get pi by 4 d square h into rho g. This is a first equation, that is a rise of liquid in the capillary tube, and this is a vertical component of the surface tension, okay, that is sigma cos alpha into pi into d. Now by equating this one, so we get h is equals to, I will get h is equals to 4 sigma cos alpha divided by rho g d, where h is a height. So now I can easily identify how much height is there. Now 4 is a constant numerical from this one, then sigma is a surface tension, cos alpha is an angle of contact, then rho is a density of a liquid in this one, then g is a gravitational constant and d is a diameter of a capillary tube. Now it can be observed from this equation, it can be observed that for alpha, that is if the alpha is between 0 and 90 degree, if alpha is greater than 0 and if it is less than 90 degree, it means if alpha is 0 between 0 to 90, then h is positive, means h is positive means it is coming in the upward direction, that is a capillary rise we can say that. If alpha value or the angle of contact between tube and water is less, it is in between 90 to 180, if it is between 90 degree to 180, then h is negative, then it is a capillary depression or capillary fall, we can say that. So even now you can now you have got a difference between what is capillary rise and capillary difference. For both the condition the same equation is used for both the condition, the same equation is used to identify the capillary rise and capillary fall. The only difference you will get to is the angle of contact in capillary rise and the angle of contact in capillary fall. So if the alpha or the angle of contact is between 0 and 90 degree, then it is a capillary rise. If the angle of contact is between 90 degree to 180 degree, then it is a capillary depression. So hope now you got the difference. Now one more very important thing we need to observe is the minimum tube diameter. The minimum tube diameter for mercury and water. For mercury and water, it should be 6 mm. It should be 6 mm. So minimum diameter to observe this capillary phenomena in water as well as in mercury, we should have a 6 mm diameter. That more than that we can get it, but minimum we should have a 6 mm diameter capillary tube. The next, some of the important definitions we're going to see now. So the next important definition is vapor pressure. Now all the liquids have tendency to evaporate. So all the tendency to have fluids will have the tendency to evaporate, and this liquid pressure we have already, vapor pressure we have already discussed in the cavitation phenomena. Now when evaporation takes place in a closed vessel, the partial pressure exerted by the vapor is called vapor pressure. So what is that one? It is partial pressure exerted by vapor. So when evaporation takes place in a closed container, and the partial pressure exerted by the vapor is called vapor pressure, and it depends upon the temperature. When the temperature increases, the evaporation increases and vapor pressure also increases. Obviously when temperature increases means the vaporization process will increase. So when vaporization increases means obviously the vapor pressure will also increases. The next one more definition is velocity of propagation of sound. In a fluid, the velocity, in the fluids, the velocity or speed of sound is given by. So how to identify the velocity of sound in the fluid? So it is by using C is equals to K by rho, root of K by rho. Now the next one more definition is Mach number. So how we define the Mach number? It is a square root of inertia force to elastic force. It is the square root of inertia force to elastic force. The definition, simple definition of Mach number. Okay. So now we have come up with the end of this introduction to fluid mechanics, where we have discussed only simple definition and phenomena which are related to fluid mechanics. So in the first session we have discussed the density, specific weight, specific volume, bulk modulus, and these are the equations. So for revision purpose I have mentioned it. Based on these equations only the numericals will be asked in the examination, and even the definition for 1 marks the definition will be asked. So generally in a numerical in the examination, if you cross check it, so 10 marks will means 10 definitions will be asked for 10 marks, each carrying 1 marks. Okay. So here I have given list of formulas. So density is given by mass by volume, specific weight is given by weight by unit volume, then specific volume is given by volume unit weight, then specific weight is density of a fluid to density of a water, density of a standard liquid. Then bulk modulus, it is a stress by strain, that is K. Now compressibility is given by 1 by K, reciprocal of bulk modulus. Similarly we have discussed the shear stress, that is in the viscosity we have discussed the shear stress. Tau is equals to mu into du by dy, where mu is a dynamic viscosity, du by dy is a velocity gradient. Du is a change in the velocity between the two adjacent layer, and dy is a distance between the two adjacent layer of a fluid. Then kinematic viscosity we have discussed. Then the surface tension we have discussed. Again in surface tensions there are 3 types we have discussed. One is a completely liquid drop, complete liquid droplet we have discussed. In that one the P or surface tension can be identified, pressure can be identified by using P is equals to 2 sigma by R or sigma by 2 sigma by R. Similarly, in soap bubble, the density can be identified by pressure can be identified 4 sigma R. 4 sigma R. Similarly, for jet, the water jet P is equals to sigma by R. So here I have mentioned R. In equations I have derived in the form of diameter. So no need to confuse. Okay. Now again, we have in the today's session we have discussed the capillarity rise and capillary fall. So for that one we have equation, that is, as I said, in some textbook they use alpha, and in some textbook they use cos theta. So that is 4 sigma cos theta divided by rho g into d, where sigma is a surface tension, theta is the angle of contact, then rho is the density of a fluid, g is a gravitational constant, and d is the diameter of capillary tube. Now similarly, the velocity of sound, that is, can be given by k divided by rho. So this is a k divided by rho. So hope this session based on the introduction to fluid mechanics, that too first half part we have discussed, and in the next session we will going to discuss the very important topics, that is pressure measurement. So again, in pressure measurement, what are the types of pressure measurement instruments? So generally in fluid mechanics, what are the different pressure measuring instruments we use? Then we discuss the different types of manometers, and how to identify the pressure by using the manometer, what are the equations for manometers. So we're going to study in details about the pressure measurements in the next video. So if you are having any doubts in today's session, please comment it in the comment box and we'll try to clarify your doubts.
Click on subscribe button and press the bell icon to get updates from Allacademy.